All right, welcome to another episode of Programming in App Inventor. This is actually the first episode I'm doing, and this is the first program that I ever wrote in App Inventor. And this is intended again for my Redlands Conservatory class, but absolutely anybody can follow along. Now, I will try to do this as fast as I possibly can, but just to quickly let you know, if this application works out, it's going to teach you basic animation techniques. It's going to teach you how to loop an animation on your phone, and we're going to put that all into a slick little application, which is a metronome. So the classes where I teach also teach a lot of music, and this is for our musician friends to have something they can run on their Android phone and use when they are practicing their music. So the app is coming up now. Let me boost the volume so you can hear it. And as you can see, we have a beautiful three-dimensional metronome here, which is running from App Inventor, and is giving us the beats per minute here at 60 beats per minute. We have a couple of buttons here where we can increase that all the way up to about 130 beats per minute, which seems to be the limit that an Android phone can smoothly move this animation. After that, we get sort of dropouts, and it's possible we could speed up the code. Maybe that's something you could help me with. As I said, this is the first application I've put together. Now, I've been teaching Scratch for a little while, and moving over to App Inventor, there are similarities. I think it's going to make it easy for you, but I've spent a few days sort of pulling my hair out with App Inventor. So part of my goal today is to save you from losing any hair the way that I did, yanking my hair out when I was trying to figure out the differences in the two, because actually there are quite a few differences, even though the overall look and feel is very similar. So let's go ahead and we will boot up and start a new program, and I will try to put this together as fast as I possibly can for you. Now, a real quick thank you I want to say to Inma Voldivia, and she wrote a tutorial on how to do image sequences, which is where I finally got a little bit of a footing here in order to put this together. So here's the finished application, but rather than jumping to that, let's build it very quickly from scratch, and you will be able to see exactly how this all goes together. So we'll just start a new project, and how about if we call it metronome, and we'll call it Y for YouTube. Looks kind of cool, metronome Y. And we will say OK. Of course, my project cannot start with letters or underscores. Well, there we go. I'm once again learning. We'll just make it metronome, no underscore, I guess. So metronome 2. How about that? And we will say OK. OK, it likes that a lot better. So we're going to start off here by preparing our screen. Now, everything that we're going to do in App Inventor, we're going to need to do on a canvas. So we'll go to Drawings and Animation. Let's grab a canvas, and we will yank it out here on the screen. We want to set the size of the canvas. Right now it's automatic, but because we want to fill the phone, and I've got a couple of neat tricks for this that I'll show you down the line. We'll just say Fill Parent for the width. We'll go over to Height, and we will also say, whoops, Fill Parent. And even though, oddly enough, it doesn't show you that, this is done correctly, and that's going to fill the parent when we load it up with a sprite. So we're going to need an image sprite. One of the neat things about the animation I'm going to show you is that it is scalable. So the big advantage you're going to have is even if you do an animation that has hundreds of frames, you're not going to have to add any additional code. It's just going to be able to handle it for you. And I know from experience, actually, we can leave the interval at 100. It really doesn't matter. Just taking a quick look at everything here before we jump over to the blocks. And let's go ahead, at this point we can upload the files. Now, for an animation sequence, we'll go to Upload File here. I went ahead and I saved a metronome here in 5 different positions with a little bit of motion blurring just to make it slick. And I've got some arrow keys and I've got that metronome click. So we'll upload these files into App Inventor, and unfortunately that takes a few moments. So we'll say OK, upload the first file, and it's going to appear over here. And I'm going to upload these quickly and speed up the video here so I won't talk while I'm uploading them. Let's upload the others exactly the same way. Okay, very cool. So we have our 5 files uploaded, which are the different positions it's in. You can do this with any animation sequence you like. Let's upload one more. I'm going to just upload the metronome there so that we have that metronome sound as well. And we're going to do one quick jump. Now, in order to write our program, we jump over to Blocks, which will take us to where we're going to construct our blocks. And the first thing we're going to need to do is there are going to be 2 variables in this. So let's go ahead and we'll bring out a couple of variables. When you are going to use anything which changes value in the program, you have to tell the computer ahead of time that you're going to be using that variable. So one will be frames, which will cover the frames of the animation, each of those being a different picture, and the other is going to be toggle, because as I said, we want this to be a looping animation, so we're going to have a toggle so that it toggles forward and backwards. Jumping over to math, we'll just initialize both of these to 0, and then we will be ready to use our variables. Now, another thing that we're going to need to do, we'll jump back very quickly now, I forgot to do it, to our designer, and of course if we're going to have a clicking, we're going to need a clock, and I think clocks are under sensors if I remember correctly. There it is. So just drag a clock out, drop it. The clock is of course invisible, but it appears down here as a non-visible item. So let's zoom back to our blocks. Okay, so now that our clock is in place, we'll come over and grab one of our clock functions. This is actually going to serve as our main loop, because every time the clock fires, that's when we're going to have the next sequence of the animation take place. So let's see, what do we need to do? So if our clock, and we're going to be dealing with our toggle there, equals 0, that would be a good starting point, wouldn't it? So let's grab a couple of if loops out of here. We'll throw an if here, and we will throw an if below it, and we will go ahead and use a math function. I think we're going to use that since we want to know our starting point. So there we go. And we're going to use our variable, so we will say if, and get, strangely enough, in App Inventor, this is a strange way for it to interpret variables, but it'll say get, and that will give you the value of that variable. So if toggle, because as I said, we're going to toggle whether we go forward or backwards. So then if toggle equals math 0, the toggle is essentially a flag if you've done other types of programming, so that if it's a 1, it'll do one thing, and if we toggle it to a 0, it'll do another thing. Then we will want to set those global frames. So let's go ahead and we will go back to our variables, and we will do set our global frames, and we will need to set them to a number. So let's use a math function here, because we're going to want to go from frame to frame. So we will set our global frames, zooming back over to variables. I know there's quicker ways too, when I've been watching people with this, to duplicate work that you've done, and it works really super well. Runtime error. So I've noticed we get these, it's a lot like other languages, that you get a lot of errors while you're working, and you can actually just dismiss them until you get to the end and then see if they're really valid errors. So over here at math, we are going to go ahead and we're going to say, so we're going to set our global frames to global frames plus 1. So it's going to start out as 0 when we initialize it, and then if our toggle is 0, which it is, it's going to set us up to frame number 1. And we have 5 frames of animation. So that's a good place to start, with frame number 1. Now again, I think actually that we could probably do that duplication trick here. If I pull this out, I can duplicate this, because we're going to do the same thing twice. Let's put this back in, and that might save us a little pulling stuff out. So if global frames, if the toggle were to equal 1, then we're going to want to do everything backwards. So we'll set that to 1. So this is the if statement for if we're moving forward. This is going to be the if statement if we're moving backward through the animation. As I said, one of the things you're going to really dig about this is that this is totally scalable. You could have 1,000 frames and do a movie if you wanted to, or a complex looping animation that could run on the phone or anywhere else that you would like. So let's go ahead, and you know what, we're going to use this one as well. So we will duplicate this, just save ourselves a little bit of time, and let us see. However, in this case, now that I think about it, we're going to want to, if we're moving backwards, we're going to want to go down 1 frame. We're not going to want to go up. So why don't we just make it plus minus 1. If you would prefer to be a little slicker, you can go over to your math functions and you can make this just to get global frames minus 1. But we'll do plus minus 1 just to save a little bit of time. Let's see, what would be the next thing we would need to do? The next thing we're going to need to do is to see that image. So I have to think for a second, only because I'm still quite new to all of this. So we'll go to Sprite Image, and let's scroll down until we find, what would it be? It would be Set Image Sprite in Picture. So here we go. This will probably work. So we will put in set, this block should be connected to an event or a procedure. Okay, it is. And I don't know why it's giving us this warning. It didn't do that when I set up the program the first time. But image sprite number 1, that's fine. Picture's good. Okay, this should fit with all the blockets. And let's go ahead and move ahead, and we'll see if this is going to work. I don't know actually why it's doing that. One of the really super cool things here in App Inventor, is that string handling, well, there we go, now it's happy. Okay, I guess I should have just moved ahead. String handling is pretty straightforward, and that's what we're going to build here. A string is just a collection of letters as opposed to a collection of numbers. So we're jumping over here to join, and one of the neat things is if you hit this blue key, we can actually add more elements to our string. And I know that our string is going to have 3 components, and I'll show you exactly why that is. So let's zoom over to text, and we're going to grab something where we can, a quote, where we can actually type in whatever we would like the beginning of our string to be. And because our files, let's just jump back to the designer to show you the files, are A1, A2, A3, A4, A5. If we're back in blocks, we're going to want it to be A, and then we're going to want it to be the number 1 for our first frame, but we're going to do that in a cool way, and we're going to do that by grabbing that get global frames. So now what's happening, hopefully I can get this little error message there. It's not an error message, but this to shut down here in a second so I can show you what's underneath. There we go. So what's going to happen is as we move through the program, it's going to go ahead and it's going to put in the letter A at the beginning of that string of characters. Then it's going to put in our global frames, which is the number which we are increasing here by 1 or decreasing by 1, depending on which way we're going. And then, of course, we have to finish out that expression by going ahead and putting in the rest of the file, which is it's a .jpeg, right? JP. Did I get it? JPG. So .jpg. So what's going to happen is the frame that's going to be displayed of our animation is going to be A, and then we're going to have it be number 1, because we start with number 1, and then JPEG. And when this goes to number 2, this variable will change. So our string will change. It'll be A1, A2, A3, A4, 5. Very cool. Now here is a little trick. I love the way procedures are handled also here. And what we're going to do is we're going to make a procedure for the toggle, which is outside of the main loop here. We're going to do the same thing when we add sound, because then we won't have any delays as we move through this. And it's neat that in both these languages you can have them do co-processing, multiple things at the same time. So let's do this super fast again, because I do not want to take too much of your time on the video. I want you to be programming and having a blast with this as soon as we can. Okay, so there we go. A couple of quick if statements, and we're going to go and do the same thing. We're going to use a couple of math functions for our toggle. So we will go ahead and we will say get the global frames again from variables. So get global frames, and we know that there are 5 frames, so we're going to make this a 5 so that it will grab all the frames up until it gets to 5. Cool. And the next thing that we're going to do is let's go ahead and duplicate that, because we're going to want to do this for the other side of the toggle, and we can set that aside for now. Let's see, we can actually put this in place now that I think of it, and we can put this in place. So this is when it hits 5, it's going to activate this side of the toggle. So we also want on the other side of the swing, put a number 1 so that when it hits 1, it'll swing the other way. And then all we've got to do is set our global toggle to go between 1 and 0 each time it moves through the routine. And again, all this is up here. You can stop the video and look through the steps, think it through. It's actually harder to explain than it is to do. You'll see very, very quickly. So let's grab a couple of the variables, and we're going to set our toggle here. Set global toggle, set global toggle, and as I said, we're going to toggle between 1 and 0. And I hope that with this language, these explanations, and looking at the code, make it super simple. We're going to toggle between a 1 and a 0. So all that's going to happen is it's going to go through this routine. It's going to call this routine. So we better get up in procedures and tell it to give that routine a call. We'll give it a name. Why don't we call it toggle? Toggle. Okay. So that we're going to run through this. We're actually done with our program here, and this is going to run in just a few moments. Let's do a couple of things just to make it a little slicker. Under Media, if you come down to Sound, let's pull a sound effect into our project. It goes down here in the non-visible properties. For the interval, let's go ahead and bring that down to a small number, to 5, because we don't want our sound effect to take a long time and have that actually slow our metronome down. There are workarounds where you can correct for that, but this is the easiest way. Then we have to specify the file. As you remember, we uploaded that metronome click, so we'll just say OK. I had one of my students just make a popping sound with his lips, and it actually sounded better than my antique metronome sound that I actually sampled off of the internet. If we zoom over to screen, there's one quick thing that we can do here too, which is a good idea. Let's see. Screen orientation right now is unspecified, meaning that it can flip back and forth. But for my particular animation, I wanted it to be landscape, because I wanted the metronome to be very large. So you can click that, and we can make it so that our metronome is in the landscape mode, and it'll always be wider side to side so they can see the swing of that hand. Let's go ahead and we'll zoom back to blocks. If we want to add that sound effect, our sound now appears here. All we have to do is do call sound play, and we will put that down here at our toggle. Now the reason we're putting it at the toggle is so that when the swing of the arm reaches its maximum extension, 5, the 5th animation, it'll do a click sound. And then when it toggles and swings all the way back the other way to the first position, we'll go ahead and we'll add another click there. So let's see, where's our sound? Sound and sound play. And I believe our program is actually ready for testing. That wasn't so bad, was it? Let's go ahead and we will load the emulator. This takes a heck of a long time in App Inventor, so we've just got to wait around for it, but I will speed up the video in just a moment. First, before I do that, when this appears, if you click on your emulator and then you hit Control F11, we can also put it into landscape mode, which is very, very handy. So I'll just be quiet and we'll speed up the video while we load it and find out if this is going to work the first time. Wow, and there it is. It always scares me when something works perfectly the first time. It's moving very, very slowly, but let's go ahead and zip back to the designer. And we know that it's moving super slowly. That would be related to our clock. Here's where we click on clock, and we can set that interval to whatever we would like. If we want it to move very fast, it could be a 1, or the bigger the number, the slower it's going to move. And then let's move back to our blocks, and we'll see if that affects our emulator, which it should. Let's pop that emulator up again. There we go. Perfect. So you've got a metronome, and currently you can change the beat of the metronome by just changing the timer of your clock function. Now, rather than go through all the steps, let me turn that volume down a bit, which would take quite a while on the video, of how you make the metronome settable by the buttons, I'm going to skip ahead here, and we'll go ahead and load a project file where I already have that done. We'll zip over to My Projects, and we've got Metronome 2, which I believe this is the one that was the completely finished version. So I'm going to simply jump over to the code blocks. I still hear it running, so maybe we're doing 2 at the same time. Now the code blocks look complex here, but they're not. This is essentially the same code as what we just did with the click. I actually added another subroutine where the click happens outside of the toggle so that we could get a little bit higher speed, and the click would never, as I said, there's a little workaround, would never interfere with the speed of the metronome or the clock. And I added a couple of functions, the timer enabled functions here. Actually, I thought they would steady the metronome, but they didn't. So these two, this function and this one, which are different from what you just entered, you don't need to worry about that. And I added a screen initialization that just simply sets the metronome up to start at 60 beats per minute. So that's all that is. So here's what I found. This looks complex, but it's not. You'll notice it's the same 3 commands over and over again. But it sets the timer here by setting the clock interval to a specific number. And each of these numbers is for a different tempo. And the way I found the tempo was by using a music program and simply changing the tempo manually, as you saw we could do in the old program, until the music program told me I had hit a tempo of, in this case, 130 beats per minute, 120, 190, 80. So this, as I said, this looks like a complicated bunch of coding, but it is not. It's just the same thing over and over again because I wanted the App Inventor to just go when you click a button from one beat to the next beat. So let's see. I'm not sure if that metronome has... Yes, it's brought up the actual thing. So this is what I meant by that. When we press the button, it goes to 50, 40. I wanted it to step through those. So I essentially made another toggle function which just goes through the different beats per minute. Yours could be infinitely settable, which would be a lot easier to code, to tell you the truth. But I'm going to just scroll through this. You can look at this code at your leisure. As I said, it looks big, but it's not. Let me just scroll through slowly. You can pause the video at any point and rebuild this yourself. You've already built 90% of it, and using that duplicate function where you can just make these 3 and then duplicate them, I had 11 different tempos you could set it at. And so you would simply duplicate these 3 commands with the if statement 11 times if you want to have 11 settings, or you could have additional settings, or you could have it just be where you can adjust by changing your clock interval, have the clock have an unlimited number of settings. I just thought normally for music you want to say it's 90 beats per minute or 100 beats per minute or something like that. So that is it. your App Inventor metronome and also how to do animation sequences. Super simple. And here's the overall complex thing. The web page, which will be specified at the end here, will have all of the files if you'd like to download them, and you can put them right on your computer and get a head start that way. So thanks for watching, and I hope you enjoy. This is the first application in App Inventor for me, and I'm hoping I pull out less hair with each application. We'll put another one up each week for you.